Hello everybody, and welcome to example 3. We are looking at page 57 in the workbook, and this problem is asking us to take the integral from 0 to 2 of 1 over the square root of x dx and determine whether it converges or diverges. Okay, well, first question we might ask here is, why is this integral improper? Well, we could just draw a picture of the function that we're integrating. So 1 over the square root of x kind of has this sort of a shape to it. Okay, if you were to plot that on the integral from 0 to 2, on the interval from 0 to 2, so it's this area that we're being asked about. Okay, and do you see an issue with this function? Notice that we have an asymptote over here at our left-hand endpoint. You can kind of see that by noticing that 1 over the square root of x, if you tried to substitute 0 in for x, you would get a 0 in the denominator. That's kind of what's creating the asymptote. Okay, so the question then is, we've talked about a few different types of improper integrals. Which one do we need to use here? Okay, let's sneak a peek at the last page. And we want to choose the type of integral that goes with an asymptote at the left-hand endpoint. Okay, and notice that that goes with the first picture here, an integral of type 2. We're gonna use that same idea. Okay, so let's just refresh our memory on the logic there. The idea was that since we've got an asymptote at t equals 0, we're going to stay away from it, pick a number that's a little bit bigger than 0, and just focus on the area that takes us from t to 2. Okay, so this integral that we're trying to calculate, we'll first integrate. Let me give myself a little more space here. We'll first integrate from t to 2. Okay, and then to pick up the strip of area that we're missing over here, we're going to take the limit as t goes to 0. Okay, from the right-hand side. So there's the calculation that we need to do. And so maybe start by noticing that 1 over the square root of x, that's 1 over x to the 1/2, which we could rewrite as x to the negative 1/2. Okay, we're going to write down an antiderivative for that. And let's see, antiderivative of x to the negative 1/2 is going to be x to the 1/2. There's raising the power by 1 and then divide by the new power. Okay, do a little simplifying here. So if you divide by the fraction 1/2, that's the same as multiplying by 2. Okay, and we're ready then to plug in our limits. So the upper limit is 2. So if we plug in 2 for our x, we're going to get 2 times 2 to the 1/2, and then minus 2 times t to the 1/2 for the lower limit. And we are taking the limit as t goes to 0 here. Okay, so what do we get? Well, the first term just has numbers in it, so it's going to stay the same. 2 times 2 to the 1/2. And if we plug 0 in for t, notice that we've got a positive exponent here, so we don't really need to do any moving around of terms. We can just substitute in 0 directly. Okay, and we're going to get a minus 2 times 0 to the 1/2 for that second term. All right, well, notice that second term goes to 0, and we're left with just 2 times 2 to the 1/2, which we could rewrite as 2 square root of 2. Okay, so what do you think? Do we get convergence or divergence? Okay, well, the fact that we got a number, 2 square root of 2, tells us that we're getting convergence. Divergence would be if we got infinity or something like that for our answer. Okay, so the integral converges to 2 times the square root of 2. We've just essentially calculated the area under the curve that we drew at the beginning.